a lot of times we're brought in and it said, hey, go do this welding thing. But welding is an end assembly effect of all of the upstream and downstream processes, and those things affect how we do things greatly. Your upstream processes are absolutely vital. We've seen before where we've got companies that are on the value end of the spectrum. Their parts, and they really want to use a robot to reduce labor, but what they've got is low quality parts that are coming into the cell. The reality is, in order to overcome the challenges of inconsistent parts, we have to add a lot of technology and a lot of cost and a lot of customization to the robotic cells. Welding has certain part quality requirements. So things like making sure that we have the surfaces have been properly prepared, making sure that the joints are consistent. It's a huge problem that we see with welding is that you may get a part that is hand ground. This is something that we've seen before where a part has been deburred manually, and they go through and it creates a slight amount of waviness in the joint. That may not be a problem with a manual welder because they, particularly with TIG, all they have to do is pump the pedal a little bit more. They can get a little more fill. Robots can't do that. Robots we can add technology that will help with that, but you're going to have effects on the back end of cycle time. We can do a lot of things. We can do a lot of amazing stuff with the new technology that's available as far as imagery systems and computer vision and laser scanning and touch sense, capacitive inductance, through the wire sensing. All of those things can be applied, but frankly, if that part's supposed to be round and it comes out like an egg and it's inconsistently egg-shaped, you're going to have problems. The most important thing on upstream that I've seen is if you have an outside supplier that's supplying parts, are they to the drawing? So it's incredible how many times we are introduced to a company or we're introduced to a part and they give us the parts and we see that they're out of tolerance. It's really hard to build a fixture that can accommodate for a wide range of variances if the part just simply is not the part that's on the drawing. The other thing is that you may have a process upstream. We see this sometimes with a plasma cut operation. Maybe you've got an oxy-fuel cut, and the cut comes out with either a bevel that isn't supposed to be there, or the parts come in and they're not the right shape, or the cut quality creates a varying seam. The other thing that is absolutely important in the welding process is going to be the heat effects of the material. Say that you have a long sheet of hot rolled steel or a long part and it's got it consistently being crowned. When it gets into the welding process, we're going to see that metal move inside the fixture. The other thing is for leaders to really become comfortable and really aware of how are the parts actually being run today manually. The part comes in and they said, we're going to have a continuous weld on this. The head and tail has to have overlap and it's really hard. And we've asked questions like, so if a robot isn't able to go around that joint and we've got to use all this sensing technology in order to hit that joint, how are you doing it today? So we can create tons of complexity in a system to attempt to kind of do the whack-a-mole on problems that have already been solved by the manual operators. It's just that people don't know that even today that those things are being done differently.